Yes,
Uh,
it's
is-
visible.
it's visible. Okay, fine. Okay, so today's topic is one of the very interesting topic, which I cannot say is exactly related to marine. It is partly marine and partly offshore. So I'm not sure how much you guys know about FPSO. It is one of a very unique kind of vessel. So what is FPSO? FPSO is a floating production, storage, and offloading vessel. Okay, and this is not a regular seagoing vessel. These FPSOs don't do charter or a trips from port to port or cargo loading and offloading. These are stationed in one location in offshore for years, sometimes even for a straight 20 years in one straight go. They don't go for docking for every 2 years or 5 years. No, they stay in one offshore field for 10, 15, or sometimes even 20 years. Okay, so the FPSOs usually we define the FPSOs with type of mooring system and with the type of processing platforms on the top. So as I said, FPSO is a floating, production, storage and offloading. So when we say floating, so it's already a vessel. We know it floats. Okay, and the production. The second item is production. So you will see on the top you have a lot of production modules or different kind of production packages. So this is the production. Then the storage. Okay, the storage is the cargo tanks, which is below the hull. Okay, below the main deck. And offloading is when the treatment or the basic processing is done. It is offloaded to another vessel, which transfers this processed or semi-processed crude to a refinery. So FPSOs usually have three types of mooring. Okay, it's either, excuse me, either internal turret, external turret, or spread mooring. Okay, the photo which is on the top in the center is a internal turret. The picture at the left bottom is spread mooring, and at the right bottom is external turret. I will explain what is turret and what is internal, external, and spread mooring. This is how a conventional FPSO looks like. So the structure which is at the forward is a turret. And then you can see number of process platforms on the deck. This is a very typical example of a FSO. So this is floating storage and offloading. This doesn't have any of the process platforms or the process modules. So you can see the entire deck is empty. This is just, it just looks like an oil tanker with a turret. That's all. Okay, so what is a FPSO? An FPSO is a floating production system that receives fluid. When I say fluid, it's a mixture of crude oil, water, and other chemicals or gases or produced water from the well. Okay, from a subsea reservoir through the risers, which then separates the fluid into crude oil, natural gas, water, and impurities within the topside production facilities on board. So the modules which is on board the vessel, it does all this operation. It separates the crude, it separates the natural gas, and there is, if there is water and other impurities. Then this crude is stored in the storage tanks of the FPSO and is offloaded to a shuttle tanker. Okay, most FPSOs and FSOs are ship-shaped and can be secured to a seabed via a variety of mooring system, the choice of which is determined by specific environment. Okay, so as I was saying, for a FPSO, this is two very important deciding factor. One is the mooring system and one is the process platforms. What kind of process platforms are present on the deck? So as I was saying, some of the FPSOs can stay in one location for 20 years or longer. And this is how a FPSO, a regular FPSO looks like. So you can see below is the storage tanks, which is all the COT tanks or cargo oil tanks. Then you have number of topside production facilities. You have the offloading facility at the aft. Then you have the mooring system, which we call the turret, and the mooring lines going to the seabed, and the production lines coming from the subsea well, coming to the turret and going to the process platforms.
Sumit, my screen is not moving. Is it only me or anybody else?
For me, for you only.
Same?
It's clear
Okay.
for our.
Okay, Sumit. So sorry. Proceed. Okay.
Okay.
My network. Okay.
Okay, so the three different kind of FPSOs that we have, as I said, is internal turret, external turret, and spread mooring. So this is what an internal turret looks like. So when I say turret, this entire structure is called turret. Or even in this left bottom picture, if you see this entire structure, which looks opaque, is a turret. So what is a turret? Okay, I believe you guys will be knowing what is a DP system, dynamic positioning. You must have heard DP0, DP1, DP2, DP3. Okay, those kind of vessels. So this turret exactly do the same job of a DP, but in a much simpler way. Okay, here in this kind of vessels, there is no DP at all. So how does a vessel stay in its position? So this acts as a very simple mechanical bearing, and this turret is moved to the seabed, and it allows the vessel to go around the turret. So there are some parts which I will show. You see there is a main bearing at the top and there is a lower bearing at the bottom. And there are the chains which is connected to the seabed, which is moved to the seabed. And then the risers. These risers are the risers which is coming from the seabed, which brings in the oil. So the internal turret is integrated into the bow end of the vessel and is supported on a large bearing arrangement inside the moon pool. So as I was saying, there is a main bearing, and this section, this cutout section is called a moon pool. Okay, the internal turrets are able to support large number of risers from the seabed. So these kind of turrets are only installed when there is comparatively a large number of risers are coming from the seabed to the vessel. And also the second important criteria is internal turret can be used in deep waters and mostly for severe environments where you have wave up to 18 meter. So internal turret is mostly used where it is harsh environment and when there are number of risers are much higher. Then we have the external turret. So this is how a regular external turret looks like. External turret is a steel box structure extending some distance from the bow of the vessel, providing a foundation for a rotating bearing arrangement and a turret structure located above the water. Okay, this is suitable for wave heights about 12 meter. So external turret is used for average waters where it is not too harsh and it is not too calm, and it can support very limited number of risers from the seabed. So this is also the external turret mooring. You can see in the picture here. There are chains which is connected to the seabed. This is the mooring, and then there are the risers in orange. These are the production risers which is coming to the vessel. So when I keep saying turret, what is a turret? A turret on a vessel that is moved to a seabed and at the same time allow rotation movement of the vessel, which we call as weather vaning, through the integrated rotating part in the hull. So as I said, this allows the vessel to move around it no matter what is the case, whether it is the wind or the waves or the current. So the vessel stays in the same position, it just moves around this turret. And this is a swivel stack. This is very important part on the turret. Okay, this is an entire turret. And the top section of this turret is a swivel stack. Okay, this swivel stack, what is the role of a swivel stack? This picture will show a display of a swivel stack. So whatever oil or gas is coming from the risers, okay, when the vessel is moving around or rotating around the turret, this swivel stack makes sure that the risers are not getting entangled or is getting messy. The reason for that is it works very similar to hydraulics on a crane or a JCB. Okay, where a crane can do a sleeving operation in 360 degrees without stopping. Okay, because the oil keeps on passing from the pipes to the necessary equipments or winches. Okay, it almost works with the same principle that it receives the oil or gas from the subsea and it pass to the topside modules without interrupting. So the vessel doesn't have to come back to its location or the risers doesn't get entangled.
Mr. Summit, can I ask a question?
Sure.
When we use the turret, is there any anchors at the end of the chain or what?
Yes, sir. There is an anchor, but that anchor system is also a very vast topic. There are number of different types of anchors. Some are even pile type anchor or some are suction anchors. This is not a regular drag anchors, mostly for internal turrets and external turret. The clients or the big companies like Shell, BP or ExxonMobil, these guys will be working on these kind of vessels. So they go for suction anchors mostly. Suction anchors is a very simple concept. Is a big tubulars which is how to say is erected on the subsea, and then the water is pumped out from the tubulars, so it will self penetrate itself in the seabed.
Yes,
So
يعني in the turret we use special types of anchor than usual.
yes, most of the times is special because these are meant for rough seas. For internal turret and external turret is around 12 meters wavelength. But still, yes, we go for a special type of anchors.
Yes,
But
thank you.
on the spread mooring, the anchors are pretty simple. It is drag type anchors, which you have seen in some of the vessels. Means not a regular seagoing vessel, but it is a bit different, drag anchors.
Okay, thanks a lot.
Sure. So this is how a swivel stack looks like. So it gives swivel stack is a toroidal swivel system installed on the top of the turret that allows continuous transfer of fluids from the well to the platform, that is export. Okay, and with uninterrupted power and control also. So everything goes through this to the subsea, or everything comes from the subsea through the swivel stack. Okay, and then there are some mooring systems or the turrets, which is detachable type or disconnectable type. Okay, as I was saying, the internal and external turrets are for harsh and average climate conditions or weather conditions. But there are some cases when the weather is getting worse. Some of the FPSOs or these kind of vessels which are working in North Sea or Gulf of Mexico, and they plan for it that during the harsh environment climate or any of those conditions, they should be able to move quickly. In those kind of vessels, we have to go for a disconnectable turret. So they will not have a conventional internal turret or a conventional external turret, which is fully welded to the hull and it cannot be removed in case of emergency. But these turrets are just removable or disconnectable type. There are two types of disconnectable turret mooring: submerged turret production and riser turret mooring. The one on the left side is the riser turret mooring. The one on the right side is a submerged turret production. So this is how a submerged turret production looks like. You can see that this turret is detached on the right hand side picture, and it is just floating below the water, and it can be easily reconnected. So submerged turret production consists of a buoyancy core and integrated turret, which provides the required buoyancy to the attached risers and the mooring lines so that when disconnected from the mating cone, it will float in an equilibrium position of 30 to 50 meters below surface. So in this case, it is still moved to the seabed, only the turret, and the risers are still connected, but it is disconnected from the vessel. So in this case, the vessel can move from the position and come back after the storm or the weather condition is fine. This is the riser turret mooring. So this is also similar. It can be disconnected and can be easily reconnected after the vessel is in place. And the next one is a spread mooring system. The spread mooring system does not require any kind of turret. Okay, and this is for ultra calm waters. Okay, so this is mostly in Nigeria or South Africa, where we have calm waters. So most of the FPSOs are spread mooring in those locations where we don't need a turret. So this is how a spread mooring FPSO looks like. There will be a riser balcony on both the sides. So all the subsea pipelines or the subsea risers are connected on both sides of the vessel, both port and starboard in the midship area. If you see in the midship area, this is all the risers that is coming from the seabed. This is the production lines which is coming to the vessel. And then the mooring is a standard mooring in the forward and in the aft area. You can see these are the mooring lines. So it is moved to the seabed. And this, as I said, it can have a conventional drag anchor.
Mr. Summit, please, one question, please.
Sure.
Yeah, these connection lines, these are connected by divers, correct?
It is not connected by divers. 99% it will be connected by ROVs.
Okay, ROVs, okay.
Yes.
So these are commercial?
Yes.
Not divers.
Okay. No. It is usually not divers, because even at this depth, sometimes the diving is not possible. The deepest spread mooring system is 1,600 meters. So I don't think 1,600 meter is possible for any commercial diver.
Okay, clear. Thank you.
Mr. Summit, can
Yes.
you please repeat the connection part? It was lagging with me and I can't hear.
Okay, for this connections means you are talking about how it is connected.
Yes.
Okay, as I was saying, on this spread mooring
And
system.
I have a question. I don't know if you explained it, but
Sure.
since there is no what's I forgot the name. Since there is no turret,
Yes.
then how the spread mooring will rotate?
No, that's what I said. This is for ultra calm waters. It doesn't need to rotate. It just stay in its position, and whatever small wind or small wave, it will take it.
Okay.
It doesn't rotate along its axis, or it doesn't rotate along at all. It just
Is it
stays.
because of the connections it have?
Not because of the connect. Yes, it is
Then
one reason that it will keep it in position, all the risers and all the mooring systems. But these kind of FPSOs are only located in those areas where the water is extremely calm.
okay, thank
You
you.
don't expect any big waves or current flow.
Okay.
Mr. Summit, but in case of turret, we have a possibility of rotation,
Yes,
right?
yes, right.
Okay.
So this is how a spread mooring system looks like, or a spread mooring FPSO. You see on this bottom left picture, entire thing on the midship to aft area is all the riser balcony. So these numbers of subsea pipelines will be coming to the vessel. Okay, so well fluid separation. As I said, the production risers, these are the production risers which are coming from the seabed, bringing the oil to the turret. And then we have the turret, the riser balcony or the turret, where the oil comes in. This is the turret and the riser balconies are here. And then we have the separation modules. Then is the processing takes place. So this is how a regular FPSO looks like, or we classify it. Okay, on FPSO on the deck, you will have number of production modules. So this production module can be very different from vessel to vessel because it is decided by the field. Okay, this particular field, what kind of treatment or what kind of processing is required. So this is purely based on the study in each oil field. So it can be different for FPSO to FPSO. But there are some very basic modules or process platforms which is always there in all the FPSOs. So you can see starting from 20 is the turret. Okay, and then if you see from number 1 and 2 is oil separation. Number 1 and 2 is oil separation. Then 4, 6 and 7. 4, 6 and 7 is gas compression and gas treatment. So whatever gas is coming from the well, it is treated as well. 9 and 10 is water treatment. So whatever water coming from the well is also treated and is pumped out. 11, 12, 13, 14, 13, 14, 16 and 19 is power modules. Mostly these vessels have a steam generator or a gas generator on board vessel. Okay, which supplies the power to all these modules and to the vessel as well. Okay, when I'm saying these vessels have a power generation system, you may ask that this is a vessel, it should be having its own generator and the main engine. What happens to those? Okay, first I will inform about the main engine. In these kind of vessels, the main engine is there, but it is only used for one last voyage to the field. And after that, it is never looked after or never maintained, because this is its final voyage to the field, and then this vessel is scrapped after maybe 20 years. So main engine is one last voyage, and the auxiliary generators is only good enough for a hotel load, for accommodation only. But for this kind of process modules which require very high power requirement, so for that we need a power module. So mostly it is gas turbines or steam. This is an example of another similar FPSO. You have HP, LP separation, gas compressors, same the power modules, power generation, laydown areas, in water injection, chemical injection. So each module is a big topic on itself, like water injection or chemical injection, when we need to do the chemical injection, when we need to do water injection. Water injection is done when the well is getting depleted, because well is a big cavity below the seabed. You cannot just pump out oil and expect the well will not collapse. It will collapse. So you have to fill it with something. You have to fill it with water. Chemical injection is done when the production line is having scales. To remove those scales, we do chemical injection. So every module has its own purpose, and there is a lot of different kind of modules. So these are some of the individual modules. We make it in separate modules like this and we install it on board. And then it is integrated to each other. So you can see well fluid reception, the electrostatic, the power generation modules. These are the generators, and these are huge generators. Laydown area, sulfate reduction, de-aeration, water injection, LP and HP separation, LP-HP compression, knockout drum, and this structure is called flare boom. Okay, usually this flare boom is one of the most difficult thing to install because of the height and because of its formation. If you see, if you see on this, this is the flare boom. Okay, so this is used for flaring the gas that cannot be converted or that cannot be used. So it is flared to air and it is burnt off. So this is mostly at an angle. On this vessel, it is straight, but on most of the vessels, this flare boom is at an angle. It is very difficult to install this. Okay, so I will show some examples of one of the biggest FPSOs that we have, or FLNG. In this case, I believe some of you might be knowing this vessel, FLNG Shell Prelude. This is in Australia, is stationed in Australia. And at the moment, this vessel is shut down due to a fire on board the vessel last December. So this vessel is still shut down. So you can see this is one of the biggest FPSO or FLNG that is available now. Okay, the displacement is 600,000 tons. The length of a vessel is 488 meter. Beam is 74 meter, and the height of the vessel, when I say height of the vessel, it is including the flare boom. So it means till here, it is 105 meter tall. Okay, and the production capacity is 110,000 barrels equivalent of oil per day. And the storage is 437,500 cubic. This is some of the photos of the same vessel. You can see the flare boom. This is at an angle. And this consists of an internal turret. You can see in the bow area, this is the internal turret. And this turret is the biggest turret in the world so far. This weighs around 8,000 tons. Same, it's Shell Prelude. Few pictures. And for the spread mooring, this is the biggest FPSO with a spread mooring that is available today. The vessel is Aegina. It is operated by Total. The length is 330 meters, beam 61 meter. The displacement is 499,900 tons. The production capacity is 200,000 barrels per day. and the storage is 2.3 million barrels. You can see on the bottom picture on the entire hull, on the from the forward to the close to the accommodation, this everything is a riser balcony, so it receives a massive amount of oil per day. And as I was saying, this is the only FPSO with a spread mooring that is moored to a seabed with a height of 1,600 meters. Okay, and next topic, what I want to share with you is this is very interesting for students, especially when I was one. Okay, this is a very interesting concept, SSPs, Seawan Stabilized Platforms. Okay, there are very few in the world which is built, and it is extremely expensive to build these. These kind of vessels, there are very few in the world, and they have different kind of vessels. Some are FPSOs, some are, you will see this is a FPSO. And why I'm saying there are very few and it is very difficult to manage these kind of vessel because of the diameter. This is a very unconventional shape. It is exactly round or cylindrical. So there are only few docks in the world which can accommodate these kind of vessels. The diameter of this vessel is around 80 to 120 meters. There are few different sizes. So it starts from 80-meter diameter to 120 meter. So there are very few dry docks who can accommodate them. And the purpose of this vessel or this design is the most interesting concept, because this doesn't need a turret. This is also working on the spread mooring system, but much less mooring system is required because of its shape. It is exactly cylindrical, so it doesn't have much effect of waves or winds or tides. So there are few SSPs are available. There are few FPSOs available, few MODU, Mobile Offshore Drilling Unit. There is one FLNG, and if I'm not wrong, there is one FDPSO only. I don't think there is any GTW or FAU or MSVs built so far. So this is more of a concept design, and there are very few of these in the world. So mostly that's all from my side. Any doubts or any questions?
Thank you very much for the amazing lecture.
Welcome.
Yeah, I have one question.
Yes, go ahead.
Thank you.
The SSB is a self-propelled or not?
Pardon me, say it again.
SSB, the main platform, is a self-propelled or not?
I didn't get your question. I'm sorry.
Is it self-propelled summit or not?
No, it is not self-propelled. No, it is not. I believe this shape is very difficult to have its own propulsion. It will lead to nowhere actually.
Okay, the main function of flare boom.
The main function of flare boom. Okay. So when I was saying there is a gas compression or gas treatment system on board the vessel, there will be some gas like methane. Okay, sometimes you have methane or there are few other gases which you cannot convert to something else and you have to flare it or you have to waste it. So there are some ways of using those gases. Okay, some vessels you can burn it off and produce energy, but some vessels you cannot. So in these kind of vessels, you cannot use it anywhere else. So you have to flare it. So on these vessels, you have something called flare knockout drum. So this is the last one which starts the processing of final separation of this waste gas, and then it is flared through the flare boom. So this gas is the only gas which cannot be used for anything else, or which cannot be stored for any kind of useful purpose.
Okay, thank you. Sorry, the position of turret is always in the floor of the ship?
Most of the designs, yes, it is only in the forward of the ship. It's either internal or external, because that is the most suitable place for a vessel in case if it wants to weather vane, if it wants to rotate along its axis. If one of you are a designer, you can try it on some design softwares, and I believe this is the most suitable one. Means instead of having it at the midship, where you will have equal stresses or equal kind of pressure or force from both forward and aft, it's more sensible to have it on one corner and let the whole vessel move around it.
Okay, okay.
But as I said, if one of you is a designer, please go ahead, try it. Maybe you will find something new.
Okay, thank you.
Any more questions? Anything else?
Question, please.
Yes.
What are the benefits of rotating while production?
There is no benefit actually. It is only allowing that there is no stresses on these risers which is coming from the seabed. So it is only making sure that these lines or the risers are connected to the vessel, and there is flow from the risers to the production platforms without any interruption. So that is the only purpose or only benefit that you get from this turret. It allows the vessel to turn around it, and it helps that these risers are not getting stressed or entangled, and the fluid is continuously flowing to the platform.
Thank you.
Welcome. Any more questions?
I see Amr Awad with us today. Amr, how was the lecture with you?
Really interesting. Thank you very much for this.
Can I ask a question?
I believe someone's mobile is too. Yes.
Yes, Dr. Go ahead.
First of all, I would like to thank Mr. Summit for the valuable information that was presented today. But I have a question.
Yes.
What are the reasons that make us use the FPSO?
Okay. It's a very good question, and it's a very big topic, but I will keep it as simple and as straight as possible. If we talk about Middle East region, okay, we have never seen this FPSOs in a Middle East. Okay, the reason is the oil or the well is found very close to the shore, so we don't need to have a vessel. We usually go for oil platform. Okay, because in Middle East regions, we can find oil in shallow waters. You just drill few hundred meters away from the shore and you can already find the oil. But in locations like Gulf of Mexico or North Sea or in Nigeria, you have to go further for deeper waters. So when we go for deeper waters, the distance from the subsea or the seabed to the water line is few hundred meters, or sometimes even much more. As I said, in one of the cases 1600 meter. So it is practically impossible to make a steel platform for 1600 meters. So in those kind of deep waters, we have to execute these FPSOs where the vessel is floating and the risers are coming from the seabed to the vessel. Did I answer your question?
Yes, shukran. Yes. Thank you, Mr. Sam.
Welcome. Ahmed, anything you want to add?
No, I'm just waiting for any question, if there is any question from their side before we close the session.
Sure.
Dr. Mustafa, do you would like to ask something for the students, or shall we close the session?
As you see,
Okay, look, let us close the session. Thanks so much for the valuable information. Thanks for your time as well. And thanks, Dr. Mustafa and all the team for the attendance.
thank you, Mr.
everyone.
Ahmed,
Thank
and
you.
thank you, Mr. Saman.
Thank you. Have a good day.